A pleasant day, everyone. I'm back, Professor Levitah Castil Mapatac, to discuss with you about our Chapter 2, Lesson 4 about quantum numbers. Okay, so let us define first what is quantum number. So, quantum number designates the number in various atomic orbitals and electron present in an atom. Actually, there are 4 sets of numbers through which that could complete the information about all electrons in an atom, be it energy, location, space, type of orbital being occupied, or even the orientation of that orbital, and that is what is meant by quantum numbers. So let us start with the first quantum number, and that is known as the principal quantum number, which is designated by a symbol n. N could have a value of 1, 2, 3, 4, and so on and so forth. So this represent the principal energy level, or known as the main energy or main shell of the electrons, wherein it revolves around the nucleus. So it is denoted by the letter n. And it can have an integral values of 0 up to 5. So the energies of this various principal shell will follow the sequence that K will have. This K is the symbol for the lowest energy level, that is 1. Then L equal to 2, M 3, N 4, O 5. So, what does it mean by this? If you look into this figure, as you can see here, this is the representation of the quantum numbers. So, here is the nucleus, which is at the center. This is the nucleus. And the first energy level is equal to 1. N is equal to 1. And it is denoted by K. Then, N is equal to 2, that is L. N is equal to 3, that is M. And N is equal to 4, that is N. Always remember, how are we going to know the number of electrons in every main shell? It has a value of this. So that is, let me write it here, that is when N, it has a formula of 2n squared and the number of electrons. Okay, so when n is equal to 1, it has a formula of 2n squared, therefore that is 1 raised to the 1 raised to the 1 is 1 times 1, there will be 2 electrons when n is equal to 1. When n is equal to 2, how many electrons will it be? That is 1, that is 2. Then 2 times 2, that is 4. 4 times 2 is 8. Therefore, in second energy level, there are 8 electrons. Then, when n is equal to 3, how many electrons? From the formula, that is 2. Then, 3 times 3, that is 9 times 2, 18. Okay, therefore, in the third energy level, that is 3, it has 18 electrons. And the fourth energy level, that is 2. Then, 4 times 2, you have 16 times 2, 32. So, that is how we are going to compute the number of electrons in every principal quantum number. So, do you understand now what is principal quantum number as the main energy level, main shell? And always remember, when n is equal to 1, meaning this is in the ground state. Okay? N is equal to 2, meaning your electrons is already in the excited state. So on, so forth. So n has a lesser energy compared with 2. 2 has a lesser energy compared with 3, so on and so forth. The second quantum number is the angular momentum, or known as secondary or azimuthal quantum number. this has a symbol of L. So L has a value of 0 to whatever number. But L has a formula of n is equal to 1. So therefore, when n is equal to 1, therefore your L will be equal to 1 minus 1 is equal to 0. Okay. Then when L is equal to when n is equal to 2 minus 1, therefore your value of your L is equal to 1. So on and so forth. Okay, so this is known as the orbital quantum number that determines the subshell. Always remember the subshell has that alphabetical symbol of S, P, D, F. Okay? S, P, D, F. So the value designated when L is equal to S is equal to 0, when L is equal to 1, therefore that is equivalent to our P. When L is equal to 3, that is equivalent to our D. When L is equal to 4, it is equivalent to our F sub 11. Also, you should also remember that there are only maximum of 2 electrons with S sub shell or sub level. P, it has 6 electrons. D should have a maximum of 10 electrons. F will have 14 electrons. That is for the angular momentum. So, for the azimuthal, if you are going to look into this, okay, these are the values as I have said. So, when S, the value of L is 0. When it is P, P stands for principal, S stands for sharp. It has a value of 1. When it is D, that is diffuse, it has a value of 2. When it has F, therefore it has a value of 3. That is fundamental. Its orbital shape will be 4S spherical, P dumbbell shape, D that is clover leaf. But for the fundamental, that is quite complicated. So as you can see here in this figure, this is now our S. Okay, this is our S. S has 2 electrons. Okay, and this is our P. P is in a dumbbell shape. Dumbbell shape for P. Therefore, at Px there are 2 electrons. Pz there are 2 electrons. Py there are 2 electrons. So how many electrons all in all in P? There are 6 electrons for P. For D, okay, so for this dx2y2, it has how many electrons? That is 4. Okay, this is 2 electrons, 2, then 2 electrons also, 2 electrons, summing up to how many electrons? 10 electrons all in all. So for the P, it has 6 electrons. For the S, there are 2 electrons. For the D, there are 10 electrons. And for the F, there will be 14 electrons. Okay? So that is how it is being located in the space. The representation in the space. So looking into the configuration of elements in the periodic table, so in group 1 and 2, that is an S configuration. Then on the right side, this portion here on the right side of the periodic table is the P configuration. At the center, this is known as the D configuration. And on the lower part, bottom part, that is the F configuration. So it's quite easy to know what subshell does this element belongs? Always remember group 1 and 2, that is an S subshell. This side here for the boron that has a P configuration, the center is the D configuration, and the bottom part is the F configuration. So, in the third quantum number is known as the magnetic quantum number, which has a symbol of M sub L. M sub L specifies the orientation in space of the orbital in a given energy and principal quantum number, and also the shape. It has this formula, 2L plus 1. Therefore, if your L is equal to 0, therefore your value of the subshell will be equal to the S. So S subshell will have L is 0 times 2, that is 0, equal to 1. That is why the S subshell has 1 orbital, the P subshell has 3 orbital, that is 2 times 1, it's 2 plus 1, it's 3, so on and so forth. That is for the magnetic quantum number. So, let us look into the values of your quantum number. From this table, we can see that our S orbital will have a value of 0 for the M sub L. Okay, that's 0. For the P, you have 1, 0, negative 1. For the D, that is 2, 1, 0, negative 1, and negative 2. And for the F, you will have a value of positive 3, positive 2, positive 1, 0, negative 1, negative 2, and negative 3. That are the values of your M sub L. So, looking into the connectivity of your angular momentum and the values of M sub L, that is for 0, that is S. Therefore, you have the value of M sub L 0. For P, that has how many? There are 3. How many orbitals are there in the S? Only 1. Okay. And for the P, how many orbitals? There will be 3. And it has this value, negative 1, 0, plus 1, plus 1. For the D orbital, it has 5 orbitals. And these are its value. And for the F, it has 7 orbitals and this value. So for the last quantum number is known as the spin. It has that symbol of M sub S. M sub S has 2 values, that is positive 1/2 and positive 1/2 and negative 1/2. Okay, so this will specify the spin of the electron on its axis. And sometimes this is called as up and down. And these are signified by an arrow, up and down. Okay? According to Pauli's exclusion principle, why is it that there are only 2 electrons that could occupy in one orbital? According to him, no 2 electrons in the same atom can have identical values for all of their quantum numbers. This means that there are only 2 electrons that can occupy the orbital, 2 electrons. And, of course, they will be in opposite spin, that is positive 1/2 and negative 1/2. So, as I have said, in the S orbital, how many orbital you will have? You will only have 1. This square here will symbolizes the orbital of your electron. Okay, so for S you will have 1, and how many electrons? There will be 2 electrons, but in opposite spin. So if you are going to fill this S orbital, that will have that form there. Okay, for P, how many electrons? There will be 6 electrons. Therefore, all you have to do is divide it by 2 to get the number of orbital. Okay, So that will be 6 electrons. In every orbital, there are 2 electrons. Therefore, there will be 3 orbitals. How are you going to fill this up? That is, you should occupy all of the orbital first before you go back. That is, all up, 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 then go back, down, down, down. That is for the P orbital. For the D, there will be 5 orbitals because there are 10 electrons. Divided by 2, that is equal to 5 orbitals. Okay? And for the F, you have 14 electrons. Divide by 2, you have 7 orbitals. Same process. It will occupy first all the up before you go back to the first orbital. So the value for your S, what will be your L? L will be 0. Okay? And this will be, your L will be 0. Your M sub L will also be equal to 0. For P, your L will be equal to 1. And these are the values of your M sub L. Negative 1, 0, 1. For D, value of L will be equal to 2. And these are the values of your M sub L. And for F, you will have a value of 3 for L. And this will be having a value of your M sub L. So let us apply this. Okay, for instance, we have a given of a 3D orbital. You already know this is 3D. Actually, this 3 here will be equal to your N, value of your N. This D here is the subshell, or this will be the value of your L. Therefore, what will be the value of your N? That is, N is equal to 3. This one here. And your D, you already know that D is equal to 2. S is equal to 0 for azimuthal. P equal to 1. D equal to 2. And of course, for your magnetic quantum number, these are the values. That is negative 2, negative 1, 0, positive 1, and positive 2. As a summary, we already know that quantum numbers will describe the location of your electron, okay, in the outside the nucleus. So the first quantum number will give you the energy level, and this matches the periodic table of elements. And the second quantum number will give you the subshell. What are those subshell? That is S, P, D, F. The third quantum number, this will tell you where the subshell is being held on. Okay. And finally, the fourth quantum number will describe the spin. There are only 2 spins, that is positive 1/2 and negative 1/2. So as a summary still, so symbol N, how is the rule? The rule of N is it determines the energy or the size. For the L, it will be, this will contribute the angular dependence or the shape and energy of your electrons in an orbit. M sub L will determine the orientation in space, and the M sub S will determine the electron spin. So, I hope that you have understand what is quantum numbers, and be sure to view our video so that you will have more knowledge about this topic. Thank you everyone, and a pleasant day.